In the previous two graphs, we illustrated income and substitution effects when the price of a good, in our case gasoline, increases. We'll now turn to the other case, where the price of a good decreases. We'll use as our example the case of me buying pants and shirts with a coupon, where the coupon, in effect, decreases the price of pants. We'll begin with an initial blue budget constraint without a coupon, and then show that the coupon lowers the price of pants, thus rotating my budget constraint outward to the magenta budget constraint. We then illustrate my original optimum as a tangency between an indifference curve and my original blue budget constraint at bundle A. To isolate the substitution effect that occurs along the indifference curve that passes through point A, we take the final budget constraint and shift it in parallel to get to the compensated budget that has a tangency with the original indifference curve. Notice that now the compensation is negative. That is to say, we actually have to take money away from me in order to make me just as well off as I was originally at bundle A. That makes sense. A decrease in the price of pants makes me better off. Therefore, if we want to ask how much of my change in behavior is due solely to the change in trade-offs and not to the fact that I became better off, we have to take money away from me. The tangency of my indifference curve with the compensated budget is then labeled as bundle B, and the move from A to B is my usual substitution effect. Notice again that the blue and the green budget constraints look very much like the Cayman Island budget constraints, both tangent to a single indifference curve. Thus we have a pure substitution effect. This substitution effect, as always, says consume more of the good that's become relatively cheaper, less of the good that's become relatively more expensive. In our case now, pants have become relatively cheaper and shirts relatively more expensive, that is, relative to pants. Thus, my consumption of pants increases due to the substitution effect, with the size of the substitution effect depending on how much substitutability is built into the indifference curve. Locating an income effect then, as always, implies looking at changes in behavior across parallel budget constraints, where the only difference between the budgets is the level of income the individual has, and not the trade-offs that the individual faces. In our graph, we have two parallel budget constraints, the compensated green budget and the magenta final budget. The income effect will therefore involve the change in behavior from the green compensated budget to the magenta final budget, with the initial bundle on the green budget being bundle B. If pants are inferior goods, then we know that on the pants axis, the income effect will point in the opposite direction of the substitution effect. This is because as income increases, our consumption of pants will fall if pants are an inferior good. In the unlikely event that pants are a giffen good, that income effect will be larger than the substitution effect, placing our bundle C to the left of bundle A. The area indicated here therefore indicates the segment of the magenta budget line along which bundle C might lie, in the event that pants are giffen, which then implies that shirts have to be normal. If, on the other hand, pants are just regular inferior rather than giffen goods, the income effect still points in the opposite direction of the substitution effect, because it's still the case that an increase in income for regular inferior goods implies a decrease in consumption. But the income effect will not outweigh the substitution effect, thus placing bundle C somewhere between A and B. The area indicated here is therefore the segment of the magenta budget constraint along which pants would be a regular inferior good, which again implies that shirts must be a normal good. Now suppose that both pants and shirts are normal goods. This implies that as income goes up, our consumption of both pants and shirts must increase. When we go from the green compensated budget to the magenta final budget, our income is going up. Our optimal bundle on the green budget is B, so both goods being normal goods implies that we have to consume more pants and more shirts on the magenta budget than we did at bundle B. The indicated distance, then, is the segment along which both pants and shirts are normal goods. Finally, it could be that shirts are inferior goods and pants are normal goods, in which case an increase in income from the green to the magenta budget implies that our shirt consumption has to decline, while our pants consumption increases relative to bundle B. In our final line segment of the magenta budget line, we therefore have the case where pants are normal goods and shirts are inferior goods. Notice that we're drawing that segment all the way down to the horizontal axis because our indifference curve isn't drawn all the way out to the magenta budget and therefore doesn't intersect it. If it did intersect the magenta budget constraint, the line segment would end at that intersection, as it does on the upper end where we indicated the distance where pants are Giffen goods and shirts are normal goods. Isolating income and substitution effects for the case of price decreases is therefore no different than isolating them for price increases. We begin by looking only at the original indifference curve and checking to see how much behavior will change if only the trade-offs changed, thus giving us a substitution effect. This gets us to draw a compensated budget, which gives us two parallel budget constraints along which to identify the income effect. Knowing something about what kinds of goods we're working with then allows us to restrict where exactly we will end up on the final budget constraint. There's one final point to note. It may seem that we haven't covered all the cases here because we didn't cover the case where shirts are Giffen, but we did cover the case where pants are Giffen. The reason for this is that the only way we can identify a good as a Giffen good is if we observe a change in the price of that good given the exogenous income for the consumer. What we observed here was a change in the price of pants, and we can therefore identify the case where the consumer decreases her consumption of pants as a result of a decrease in the price. That's a Giffen good. But we can't identify whether shirts are Giffen because we aren't observing a change in the price of shirts. Thus, along the distance where shirts are labeled as inferior, they might be Giffen along some part of that, but we simply can't tell where.